So yeah, I'm Sva, and I want to tell you about Pretty Easy Privacy. Here you can find the contacts, email, web, Twitter, IRC, these things. Thanks to FSec for inviting me. I was actually in contact with the Balkan people. I will also mention this later. That's a conference next week. And it's very interesting to be here. Thank you. So Pretty Easy Privacy is a project that stands at the very beginning of rolling out privacy by default for everyone. You might have guessed that the name comes from PGP, pretty good privacy. So who knows about PGP? Yeah, that's nearly everyone who's using it. Okay, who's using it daily? Here you see, we really need to get the pretty easy mode going. As this is also a bit of a corporate thing, event, who was trying to roll out PGP in a company? No one? Okay, who's planning to do so? But who's from a company though? Okay. All right, so then I can skip this one and directly go into the talk. So I'll be making an intro, then I introduced you the technology of PEP, then the concept, which is, I guess, the longest chapter, and then briefly the organization, and then depending on how much time is going to be left, the current implementation and some demos of apps. And yeah, please interrupt me anytime with questions. And also if I'm talking too fast or something. Edward Snowden said, I don't want to live in a world where everything that I say, everything I do, everyone I talk to, every expression of creativity or love or friendship is recorded. I agree. And the problem is we do live in such a world now. It's not only this, it's also that. So there is a problem that most communication online is visible like a postcard, and this world has mass surveillance. So what we need is mass encryption. That's what we're trying to do. That's just the starting point, because we also try to have mass anonymization, getting rid of all the metadata. So again, just the starting point. We just started and we see ourselves as cypherpunks, and we want to optimize the costs of mass surveillance, not only privacy for citizens, but also security for businesses. Cypherpunks do write code. It's a group making the networks safer. They defined once, privacy is necessary for an open society in the electronic age. Privacy is not secrecy. A private matter is something one doesn't want the whole world to know, but a secret matter is something one doesn't want anybody to know. Intro also includes my person. He already read out loud most of it. So I'm originally coming from the humanities. And I'm also a stolar, carpenter. There's no English word, so I'm trying to use the Croatian word. My name Sva is a unique addressing in the internet and in the web. My legal name is also a unique ID. That's why I'm trying not to use it. You can find it out if you check on the board members of the associations on the right-hand side, if you're really curious. And I'm also, organizer, enabler of various hack events, check events or media, CCCDE, and hill hacks. That's in the Himalayas. You're very invited to come. And you're very invited to come over to Balkan next week. That's in Novi Sad in Serbia, not far away, next weekend. And I already met people here who didn't know about this event. So you should definitely get to know about it and maybe even come. It's at the weekend, so you can just come on Saturday, Sunday as well. But now let's get started. Technology. I briefly explained the architecture, which consists of applications, adapters, and the engine. Then I show you a list of repositories, and a list of developing platforms. And so that's the basic architecture. So we always have an application that does things. So in this case, is an email client. At the moment, it's mainly email clients. and then it's connected with an adapter to the engine. The engine is like an API that serves the crypto and the key management functions and knows about the transport protocols, but I'm going into this more detail in the next slides. So on the right-hand side, you see the example of Outlook. On top, you have the Outlook plugin or add-on or whatever it's called in Outlook. And then you have the COM server adapter, which you need for this, and which connects then the PEP engine into Outlook. So applications we have at the moment, this Outlook add-in, an Android K9 fork, and Thunderbird, which is an early alpha, or an alpha, and a PEP for iOS, which is even earlier alpha. There's more to come. We just started. Our main tech lead is still hoping that someone would be implementing it into Mud. It's Python, so it's all there. Camel is in pipe. Then we need browser plugins if we really want to reach out to the people out there, because they're not using email clients, unfortunately. Maybe you want to suggest your mail client. If you're a developer, even more, come and talk to me. And then it shall also go into other communication, like interpersonal communication applications like SMS, like Jabber, XMPP, like Facebook, Twitter, whatever private messenger people use out there, because it's about mass encryption. At the moment, the current implementation handles OpenPGP and S/MIME without any hassle for the user. So it automatically encrypts. It encrypts the subject in line. There's no key management needed. There's no key server or any other centralized infrastructure. Fingerprints are translated into trust words. There's an opt-in passphrase for keys. So by default, there's no passphrase. And header is going to be encrypted and obfuscated. That's for the next version, and also the PEP sync, but I'll be going into some of it in more detail. So the adapter is a language environment-specific interface between the engine API and an application development environment. So this may be a language, or it could be an IDE or whatever. There's a list, the COM server adapter already mentioned. There's this Java thing for Android, there's a JSON adapter, there's an Object-C, there's a Python adapter, there's a Qt adapter. So we tried to have all the common stuff solved for the moment. If you see something missing, please let me know. But there's also more in progress. So this adapter makes calls. The app makes calls to the adapter for the function it wants, which can be, please encrypt the message, please decrypt the message, or make MIME encoding, please get the trust words, or verify the identity, or decide on the trust level for the identity, or this particular message I have here now as an application. Then the adapter converts that into normalized, standardized, and into a form, like standardized form for the engine, and makes then the C library call. Then engine magic is happening, and the adapter gives the result back to the application. Here's another diagram. On the very right, you see the Outlook again. Like Outlook, you have the plugin, and then you have this COM server adapter, which then goes down to the engine. Then on the very left, you see the KDE to KDE mail clients, which use this like KDE specific stuff, and then the Qt adapter. And then in the middle, there's Thunderbird and Enigmail, which are for all platforms. And then they use this JSON adapter and go into all those platforms, and then again, use the engine. Now the engine, that one takes care of the messaging functions, the crypto tech services, it's like a crypto API, and makes the fully automated key management services and the trust rating. It knows about the transport protocols, the message transports. In the future, it shall also do the metadata protection via GNU-net. As a developer, you can just plug and play, and you don't have to care for crypto. So the pretty easy is not only for the user, who at the end, by the way, if we look at this Outlook plugin, the person who uses Outlook installs PEP, and afterwards the person still just writes email. There's nothing that changes, but the email will be encrypted. So there is no hassle. It was mentioned that I'm coming from the crypto party movement. Lots of us are coming from the crypto party movement, and usually explaining GPG and installing it on devices, we usually did this with Thunderbird and Enigmail, took at least 1 hour. Usually you were counting 2 when you made the plan, 2 hours to get whatever, usually it's like 20 people in a normal crypto party, to get them all GPG going. It takes 2 hours. With PEP, it's going to be like Tor browser, like install and use it. And there's also, you don't even have to understand what you're doing anymore, which also is a problem, but I'll come to this later. But to come back as a developer, it's also pretty easy. So there would be developers who would be sitting there after Snowden, oh shit, I should do something. And then they're checking on a search engine, okay, how to do crypto. And after half an hour, they're like, oh my God, I'm not doing this. So hopefully they'll be finding out about PEP in the future and say, okay, great, this is my adapter. And all I have to do is to care for the interface between my application and the adapter, and everything has been taken care of PEP. And then all you need to do is to trust us that's there. But we're doing code audits, it's all open source, you can also check it out yourself. The engine does the decryption, the encryption, the MIME encoding, decoding, the message processing for the adapter, which we already had, the key management, which means generation, verification, also blacklisting if needed. Like we all know these people who have their keys lost, and then like Mua, your mail client, always takes the one which is actually lost. So you should also have the option to blacklist keys. Then also key synchronization between devices on the same account, which is a rather big thing. So far, I think only Apple is able to do that, but only if you use their cloud and whatever. And the engine drives several crypto standards on different digital channels, like different message transport protocols. It's written in C99. It's roughly 9,800 lines of code. It has regular code audits. One has already been published, and we're very happy to have more people having a look, so it's not too much. This is the list of repos. In the middle, you see most of the adapters. There is the PEP engine. There's the engine. There's this NetPGP, which is a fork of the iOS NetPGP. Then there's the internet drafts. We also started an RFC that comes later. And yeah, different things which are used. And if you look at the URLs, you already see where we're coming from. Everything is reachable on CA Cert and Let's Encrypt. But if you don't want to remember those URLs, you can just go to pep.foundation and then click on PEP software, and then you again get a list where you get led into the repos. And here are the platforms we're developing on: iOS, Android, Linux, BSD, macOS, and Windows. So it's everything, because we want to reach mass encryption, the point of mass encryption at one point. So we need to do everything. So it's quite a task, especially in the developer team. If you have Windows people sitting together with BSD people and Linux people, it's always fun. Okay, next chapter, the concepts. That's 6 points. Privacy by default, where I also show you the RFC we started as a draft, which I briefly mentioned. Then pretty easy privacy, where I also explain the key sync protocol briefly and the concept of trust words. Then the chapter peer-to-peer and end-to-end, free software, compatibility, and anonymity, where it's about GNU-net. Okay. PEP does what the user would want to do. By teaching at all those crypto parties and writing all those how-tos, we were just like, why don't we just stop explaining it all to people, and instead we write all this stuff into protocols and have software actually doing it. So instead of writing how-to guides, we write user expectations into software and protocols to automatize all steps a user would need to carry out. So we started an internet draft together with the ISOC Switzerland on the general PEP principles. It's online and ready for discussion. I guess I can upload the slides somewhere later for the URL. So the operations that are going to be automatized is the key management, key discovery, and key sync. That's the main features. This is how such a draft look like. I guess everyone has seen it before. This is a zoom in into the abstract, and this is the table of contents. I also have it here in a printout if someone wants to have a closer look. Next part of the concept is pretty easy privacy. We want to make privacy easy. Easy to install, easy to understand, easy to use, no hassle, no training needed, and also easy for app devs. I think nothing else that I need to say. It's a big goal, but I think we already reached it with the Outlook plugin, and the rest is all beta and alpha, so I cannot really say that this is really true. One part to make it easy is to translate the hexadecimal-based fingerprints into trust words. So it's battery, horse, staple instead of EC5539C8FECF, which you have to read out loud on the phone. So that we hope will make things more convenient for people, because this is the only step we cannot put into software. Trust you can only establish by looking into someone's eyes or listening to a fingerprint on a phone. And so this is what people really need to do if they want to really verify the contact. They can still write each other encrypted emails without verifying, like I would say most of us do with OTR in Jabber or IRC. When we start an OTR session, there's also like this, yeah, you know, you have to verify the fingerprints, and we're all like, yes, yes, verified, it's okay, let me go on. So there we also don't do it. So we haven't verified the partner, but if we're taking it serious, which we sometimes do, we call each other and read out loud the fingerprints. So instead of fingerprints, now we say battery, horse, staple. Yeah. The next part to make it easy is the PEP-Sync protocol, to use the same keys on multiple devices. We all know this hassle, like I'm just on the phone at the moment and I don't know, like I don't want to put my keys on my Android, and I don't know how to do that. So please write me again, or write me on OTR in Jabber, because that reaches me on the phone. So we're trying to have an PEP-Sync to get rid of this problem, so that people can really use it, and that it's not something like you can only use it on your desktop machine, which people anyway don't use too much anymore. This is realized with the help of device groups, and I'd rather explain it with that picture. So a new device generates a device key, and then the new device pings with this one in the device group. And then existing devices and the user verify the new device with these trust words as well. They make the handshake, and then they agree on a secret main group key, and then all devices exchange their secret keys, and then you have this like main group key, which is the one which external partners then communicate to, where it can be distributed on all the devices. That means you can also use your own computer to sync your keys, your contacts, and your calendar as well. And instead of using the cloud, which is just people's computers, right? So you can use your own. And ideally, you only lose your phone and not all your devices. If you lose all your devices, then you're anyway screwed. This is a real-life screenshot from testing of the sync protocol. Not released yet, will be coming with a version 2. Next part of the concept, end-to-end, peer-to-peer, like end-to-end encryption, peer-to-peer transport, and no centralized infrastructure or any kind of closed services. We don't want to create any, like, yet another crypto app that you can only use with your friends, which you have to first persuade to install this thing again, and then half a year later it breaks, and then you need to convince them to install something else. And we try to stay out of this. It's for sure compatible with every other GPG and PGP implementations out there, which is there since the early 90s. So we hope that we're not, like, we don't want to reinvent the wheel as written in the abstract. And yeah, also here we want to do things right. It's not only end-to-end and peer-to-peer, it's also free software. It's GPL, and we just recently got the acknowledgement from Mr. Richard Stallman to actually have this as well in other licenses. So because applications, like on the application layer, we want to talk to every application, and then with the GPL sometimes you cut yourself out. PEP has regular independent external code audits, also mentioned already. Then the compatibility, so there's multiple crypto technologies, multiple message transports, multiple platforms, multiple languages going to be supported. And this is an example of the crypto. The bolded part is already implemented, but then OTR, OMEMO, Signal Protocol, Axolotl, and whatever is going to be hip will be implemented. Again, not yet another crypto app, but being compatible with everything that already exists. Same for transport protocols. At the moment, all the email stuff is implemented: Exchange, IMAP, SMTP, POP3. Then XMPP is most probably going to be the next one. And then the non-open standards, which I guess will be fun to look at, but it'll be important to really create the goal of mass encryption, because that's what the people use. And then GNU-net, and even down to SMS. Anonymity. Content encryption is not everything. We all know that for email, metadata stays visible. The from, the to, the IPs where you're sending from, the subject, the size of the email. So we're trying already to, at this point of time, to encrypt, to obfuscate and encrypt the rest of the header as much as possible, and encrypt the subject inline, which is pretty easy. So it's just the first line in the body is the subject then, and every PEP client, and hopefully other email clients as well in the future, will be able to interpret that if in the first line of the body there's written subject, column, word, that word means subject, and that in the client you will be having it in the subject again, which I find very convenient. Yeah, teaching on all those crypto parties, you always have to tell the people not to use any subjects anymore, or at least subjects which don't have anything to do with the email, which is then very inconvenient when you're scrolling through your emails and you have this like encrypted, foobar emails, and you don't know where's the one you're looking for. But that's only a small thing to encrypt, or encrypt the subject and obfuscate the header. We're also trying to solve this problem from the root. So to get rid of the metadata, we want to pipe everything through GNU-net at one point. GNU-net is this project from academia, started in 2002 with the first white paper. And to explain it, I use this analogy of the internet 1.0 in the 70s and the 80s, where everyone was like, wow, I can access your computer and you can check out mine. How awesome is that? Right? This is how it was in the 70s and the 80s. They're connected to computers to each other, and it was amazing that you could, from this point, access a computer which is on the other side of the world. Nowadays, in the year 2017, we are like, sure, I can access other computers. Like, what's this? And I can use their services and all this. But wait, what? They can also access mine. And what we're trying to have is the Internet 2.0, which is going to take quite some more time, end-to-end encryption and anonymization of the way data flows. So this is this project. It has the tagline, "You broke the Internet, let's make a GNU one," gnunet.org. which is a mesh routing layer for end-to-end encrypted networking and a framework for distributed applications designed to replace the old insecure internet protocol stack. So what they're doing is to replace TCP/IP and everything above. GNU-net wants to become a widely used, reliable, open, non-discriminating, egalitarian, unfettered, and censorship-resistant system of free information exchange, and serve as a platform, as a development platform for the next generation of decentralized internet protocols. Yeah, so that's a rather big task to rewrite TCP/IP and everything which comes after it, but they're already on it since 15 years. Is this like university thing where there's a lot of PhDs written and master theses and working groups and la 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 la. And now they're kind of done, as in like it'll take some more years till our parents can use it. But for now, I hope there will be another release this year. The last release is from 2014, so please do not use that one, but clone the gnunet.org/git if you want to try it out. All the release stopping candidates are already fixed, so let's cross fingers that they actually release. And then it's really important that we as hackers, as technologists, as geeks and nerds are starting to test it, to use it, to be a node in the GNU-net to find out what's broken, because it'll be like, you know how it is when there's stuff like code coming from universities. So we need to check that out and then maybe rewrite some, re-implement some stuff, but all the crypto, all the mathematics, everything is done. And I deeply believe that we won't solve the problem out there. They broke the internet, we need to make a new one. That's the only solution to get out. Okay. A summary for the concept wrote a journalist once who said, it's the quote at the bottom, "It is this little hacker inside that decides on the cryptography chosen to communicate with the message recipient. So users don't have to think about the crypto anymore. They can just use it by default." And that's where we would like to be in some years. Because at the moment, we are all, I mean, I guess when you're here, we are all using crypto and we're deciding every day with every communication partner, with every kind of communication, again, what kind of crypto we're using. Like you're on the road, someone's writing you a GPG message, which you cannot read. You reply, "Oh, sorry, I cannot read." Can you paste it into Jabber with OTR? No, but okay, you don't have OTR or iMobile, let's rather use Omemo, or you also have Signal, great, can you paste it there? And so we're making this decision every day and with every partner we're doing. But we cannot expect this from the people out there. And we don't want to be like, I mean, I've done this, like everyone who asks me, I explain it. But being always the missionary of explaining and showing, and then people are like, "Oh my God, this is so complicated, how I would ever go into this." So why not just leave them where they are and put it under, like sneak it into their usual communication behavior. That's what we're trying to do. All right, so to do this, we founded a company, or actually two, and a foundation. So the company sells applications and services around it, business to business, as well as business to consumer, which hasn't started yet because there isn't barely anything which we can sell. But the Outlook stuff is already started, like it's already been sold. And there is the foundation, which is founded to support free software and to support PEP. And the code of the application, not of the applications, of the adapters and the engine belongs to the foundation. Because the company, as usual, gets money from investors and like government funding from the state of Luxembourg and whatnot. But we all know that this might not work out and that investors might have a different opinion on how things work. And then at one point you lost everything. So the solution of having the code being an asset of the foundation only, I find pretty nice. Like the idea was pretty good to have. So whatever happens to the company, the code of the actual engine and the adapters always stays free. Yeah, and it's Swiss and Luxembourg. So the foundation is in Swiss, the company is one in Swiss, one in Luxembourg, which looks a bit fishy if you only see it on the website, but it's because it's people from Switzerland and people from Luxembourg. That's how it is. So we're coming from fishy countries, sorry about that. Yeah, so we have 14 minutes left, that's great. So then we can briefly have a look into the applications, or is there any questions right now? Yeah. Good point. So the question was, if everything is automated, how do you know if something's working or not working? I haven't mentioned this, I should actually. We're following the opportunistic approach of, what is it defined? Some crypto most of the times. Yeah. So the opportunistic approach is also defined in a recent RFC in 7,400 something. I can look it up, and which is an approach which lots of the recent crypto stuff is following. Same with the Signal, and I think it is even some people from the Signal crowd who started this RFC. So it says, yeah, try to have as much as crypto as possible, but in case of it doesn't work out, send out unencrypted. So that's a good point, because that's pretty important. So the only indicator you have then is that it shows you, oh, this is now unencrypted. But it will not prevent, and that's the idea of opportunistic crypto, or of the whole approach, to get it out to the masses. We cannot hassle them with questions. Oh, this now failed, that one didn't work, and what to do next and all. It will only give a message, oh, this will be now sent out unencrypted, done. So there is no real error communication with the user, which is part of the concept. If you're into this, if you're into the whole security stuff, then you don't use PEP. Thanks for the question. Any more questions? Yeah, the question is Gmail. What about Gmail? Everyone uses Gmail. It's, yeah, a problem, but web plugins. I was mentioning somewhere in some line that one of the things we're taking on next is to have those browser plugins that can then work with Gmail and all the other web applications. There's already this mail envelope, it's called. I had this in India actually, that people were asking for this, and I was like, no, don't touch like web technology, oh my god, and crypto, don't even start. But then they were like, but I don't have a computer, right? I like, how should I now do my emails encrypted? So I had to have a look in it. And it works. You can have it on a stick. You have your keys on a stick. You have it like a to-go thing on a stick. So when you go into an internet cafe, you plug it in, and then you can use your keys and you can decrypt your emails in the web interface. I don't know how it actually works. I guess there will be somewhat of an application on top, so it will not be your Gmail window anymore. But yeah, like we're all like, okay, let's take on the gloves and look into this web shit. Let's see if that happens. Maybe we get like the problem of web also is going to be solved. But yeah, thanks for the question. Web plugins is very important to get the people. But when they're all using now their mobile devices, they actually start using email clients again without even recognizing it. Any more question at this point, or shall I show a bit of the apps? All right. So this slide we already had. That's the current implementation. And what we have is this Android K9 fork. It's ready to use. You can get it from Play Store and from F-Droid. In Play Store, it might be costing something in the future. In F-Droid, it will always be free. And then there is the Windows thing for Outlook, which is ready to use. That's in the PEP shop. You can click that on prettyeasyprivacy.com. But for sure, you can contact us for a testing license. Just mention that you heard this on this conference. Then we're very happy to give you a testing license. Then there is this Thunderbird Enigmail, which comes then with the next release of Enigmail. And the old mode still stays available. Yeah, don't worry. Which we're actually really excited because, as I mentioned, at crypto parties, usually you had to do 2 hours for GPG, and now it's going to be like install the Tor browser, done. And now the demos. Oh, there I had another question slides, but we go into this. That's the actual use case, which I show in the demo. So we have 2 PEP users, whereas the other one could also be a non-PEP user. All the other user needs to do is to actually attach the email, attach the key on the email, but let's stay with 2 PEP users. They're installing PEP, and then Alice, no, that's Bob. Bob writes an email to Alice, which is unencrypted now, so it's gray. Then Alice replies, and this one is already encrypted. How does that work? PEP generates the key in this moment already for both of them. And in this moment, PEP attaches the public key automatically. It will not even be visible. And then Alice just hits the reply button and also attaches here her private key, public key. So that means this communication is already encrypted. At this point, they can continue forever if they like. As I said before, like we do in OTR so often, we don't verify the fingerprints, we just continue talking. So in this mode, you already communicate encrypted, but you should really make this verification with the trust words. So you call each other, you say correct horse battery stable, you say yes, handshake, and then you're in the green mode, which is encrypted, secure, and verified. There's another slide which explains this. You can also see the ample semantics. So if your PEP shows red, then it's like the alarm. Then some fingerprints didn't work out or something. So the first email is unencrypted. The first reply is encrypted but not verified. And then the trust words can be exchanged on a phone line or whatever other communication channel is there. And then you're secure and trusted in the communication forever, as long as you have this installation. So in Android, you install, that's installed. You have this welcome screen after the fresh install. You set up the new account, and now the keys will be generated automatically for importing existing key. At the moment, there's a pretty stupid workaround, but the PEP sync will serve this function. That's why we didn't implement it at all in the first version. You set up the account, we'll choose IMAP. I guess that's what most of the people use. So you put in your IMAP server settings, SMTP server settings, you give the account a name, and now you write an email. So that's the first email, the composed view of the gray mode, unencrypted, plain text, but the key will be attached. So the next reply with the attached key is then the yellow mode. You now click, because you want to verify, you click PEP in the upper corner, and you get the question, like you get asked to make the handshake. So you say yes, handshake. And now the trust words are shown. So you can start reading them out on the phone. But your communication partner might be speaking a different language or having a different language installed on your phone, so you can change the language. I think meanwhile it's even more. I actually haven't checked if there is a Croatian, like server Croatian already there, but I'll be having a look. So you choose a language. So now we've chosen Spanish. So now you have Spanish words. And maybe so now we're back at the menu. Maybe your partner isn't using PEP, but using any other GPG implementation. That means you want to switch back to the GPG fingerprints and read those out loud. So you can also get those. And then you say confirm. And now you're in a secure and trusted mode, in the green mode. Now you can write emails in the green mode as much as you want. But you can also now disable. So again, oh my God, I lost my device and whatever happened, I'm in China and it's not going through. So please disable protection. Then you're again in the gray mode and get a reply back. So that's also working at any time you want to. Yeah, that's all I have here for Android. And the next is the Outlook. That's Windows 7 to 10, all service packs. And you need the Outlook, like a recent Outlook. You start the installation, you accept the license agreement as you do on Windows all the time. You give weird permissions because it's an unknown source. Then it installs, installation completed. Maybe if you have an older version of GPG for Win already installed, then there's this thing coming up and asking you if you want to overwrite the current installation or not, or whatever. So, but if you already have a GPG for Win installed, then you know what this means. And if not, this doesn't even show up. And that's all from the installation. If you want to do it like in a corporate environment, you can also do a silent unattended installation with that command, and then you're done. One of our colleagues, by the way, tried it out once with some email clients, so we are much, much faster in the installation as any other GPG solution out there. I have 2.5 minutes left, but that should just be fine. So here again, you have the unsecure gray mode. Now you're going into the secure mode with the next reply. Then you confirm the trust words, where you can again choose the language and choose to have PGP. And then you're in the green mode and you can write. You can also reconfirm the trust words. And you can also disable the protection, as we had before. Now it's disabled. You see it always on the bottom and on top. And you can still attach your key. And this is again this real life pic I had. This is actually when the colleague who was implementing it was in the testing. It was working for the first time with the key sync. This was quite a big thing. It's a bad picture, I know, but there's something behind that. And 1.5 more minutes for questions, or you just go and grab stickers, which are here. And I think I can place them at the entrance where you get this thing. So they'll be there for today and tomorrow. Yeah, that's it. Thank you.